After that, 1032 was very, very cold, and maybe 1628 BC was majorly cold.
The best systematic and detailed human records take us back only a few hundred years to the invention of reliable scientific instruments. So how do you get a detailed and long-term record? If scientists can't rely on human archives, they have to look to other natural sources of data.
What you can see here now are wide and narrow rings. You can see quite clearly the year-to-year growth. What this tells us is really when the tree was growing well and when it was growing poorly.
But a tree that's living today can take you back only a few hundred years. This is surely no advantage over the human records.
Let me illustrate it with a piece of oak which was cut down in this region. And we know that the year it was cut down was 1983. And by measuring the rings back, we know there are 250, and this takes us back into the 1700s. The beauty of tree rings in this area, or in any area where there's a strong seasonality of climate, is that they only produce one annual ring, clearly each year, and that allows us to build a unique, absolute scale of measurement. Now, once we've got back in this sample, for example, and many more like it, to the 1700s, we can take another piece of wood, like this one, which may well have come from an old building, or even a very old dead tree, and we can do a similar measurement of the annual rings. And by matching this pattern of rings, the changes from year to year, with the changes in the original sample, provided we've got enough of an overlap, we can get a unique position, a unique match, which allows us to take this scale right back another 100, 200 years, say. And by using even older samples, such as this piece of oak, which came out of a German bog, and is in fact 2,500 years old, we can continue this record back even to earlier millennia. So given a several thousand year series, and in fact in some parts of Europe these series have been able to be extended back even 8,000 years and more, we then ask the obvious question, what can we tell about the past climate in this record?
Detailed analysis of the distances between the rings, their thickness and density provides a wide range of climate information.
You can find summer temperature. In some regions you can reconstruct annual temperatures. Simple rainfall during the growing season.
You have to look elsewhere.
This is a collection of sediment cores from the world's oceans. These cores are cores through the layers of mud and sediment, and the sediment type is very often controlled by climatic changes. Some of these sediments go back 500,000 years, and this forms a geological record rather than a human archive record. Here's an example of a core that goes back some 100 to 200,000 years. And the sediments within this show clear differences visually, which have been caused by differences in climate. Now you can see here a whiter carbonate ooze, and here a red-brown clay.
Thank you.